To use any sort of supervised learning method, we would need to know the errors in the network. So how do we calculate these in a pulsing system? There are two commonly used approaches. The first of these is Crude and uses a network output in a similar way to a perceptron network. To use this method, simply work out how much of the available time is filled with pulses and allocate a number based on this, from 0 for no pulses at all to 1 where all the available slots are full of pulses. So in this case, the output value is just the number of pulses divided by the total number of slots where pulses could be. Once you have this value, you can just subtract it from the number of pulses actually required, in other words the target, to get the error. This error can then be used to train a network as the fitness in an evolutionary algorithm or directly in a backpropagation training algorithm. However, for many applications of pulsing networks, we need much finer control of the actual output waveform, and this leads us to the second method of calculating an error. The reason we need such fine control is because, as we've already discussed, pulsing networks have complex applications which simple perceptron-type networks cannot fulfill. We've already hinted at this when we discussed how pulsing networks like these might hold the key to consciousness. However, more importantly, pulsing networks can be used to synchronize and control complex practical machines or decode complex time-varying patterns. For example, suppose we want to make a walking legged robot. How could we synchronize its legs together in order to give the correct walking or running gait? In fact, here we come to the crux of the importance of pulsing networks. They can be used to provide timing signals to coordinate and control different parts of a complex system. So how do we train a network to produce such a complex output? Well, the simplest way is to use an evolutionary algorithm, but even with this, we still need to calculate the error. The way this can be done is shown on the screen. A pulse which is an error occurs when a slot should be a 1 but is actually a 0, or when it should be a 0 but is actually a 1. We can add all these individual errors up to give us a total error. In this way, the error will be a 0 when the two patterns, the output and the target, exactly match each other.